Hello. Good morning, participants. Good morning, Nagarajan sir.
Very
This is
good
Deepika
morning.
from Anurag University. Audible, sir?
Yeah, very much. Yeah, please go.
We will start in just 2 minutes, sir. Okay?
Yeah,
Thank you.
thank you.
Good morning, everyone. We will about to start this session. Before starting this session, I would like to introduce about Dr. Nagarajan sir. Sir is currently working as a president at Wyoming Global Research World Private Limited. Sir is specialized in data science and especially in Python, machine learning, deep learning, and artificial intelligence. Sir is currently working as a director, research head, academics initiative, CNGN Research World. Sir has an experience as head of the department, associate dean, professor at the premium institutions. Sir has been dedicated to working at various subjects like microprocessors and its application, digital network programming, operating systems, etc. So I would like to request you to start the session. Over to you. Thank you.
Thanks a lot for that introduction. Thank you very much and welcome to the session. most of this session, I'm going to concentrate on how we implement a project in the industry, basically. That's what would be the concentration here. Using ML algorithms is what I want to showcase, depending on uh, um, depending on the audience. I see a lot of students too. So machine learning, I thought would be a good starting off point to do this. So for doing this, can you help me share the screen?
Yes, sir.
Can you help me share the screen, please?
Okay, sir. Just there is a share screen button down there. I made you co-host.
Okay. Okay. Hope you are able to see my screen out there.
Yes, sir. Yes, sir. One second, sir. I will mute all the participants.
Body pains ki
Hello, everybody is able to hear me now? Hello. Are you able to hear me?
Yes, sir. Yes, sir.
Yeah. Okay. So let's get into the industry standard that we normally process or we follow in order to do projects in the industry, basically related to data science and machine learning or even deep learning and things like that. So first thing is to have a standard or a framework, basically, so that if a company A does the analysis or company B is going to do the analysis or the implementation, the result has to be the same, basically. That's the whole the thing of following the CRISP-DM framework, or what we call as the cross-industry standard process for data mining, basically. So this is the entire framework based on which the entire process happens in the industry. So in order to go and just look at a brief about why exactly do you require a standard, is that the data mining process must be reliable and must be repeatable by people with little data mining background, basically. See, the main purpose of putting in a standard or a framework is to see that we basically are able to showcase things or do things in a shorter time, basically. If you look at industry projects, when we used to do projects on C or C++ in the industry, it used to be anywhere between 2 to 5 years projects, basically, and that is how the initial industry used to be. And slowly when Java came, there was a reduction in time, even though there was a reduction in time as comparable to C and C++, even though projects were running up in terms of 1 to almost 2 years, depending on the size of the project. But today, with a lot of Python coming into place, a lot of R programming happening in the industry and things like that, we talk of even projects that run for 1 week, 2 weeks, 3 weeks, 4 weeks. So everybody wants things in a jiffy, basically. I remember one of the Silicon Valley clients for whom I did a project on predictive analytics. The whole project, even though we had almost about 10,600 components out there, for which we had to predict the failure of the device in advance, at least 3 days in advance for spares that are available on this machine, basically, which can be ordered off the shelf. Basically, there were products which were even taking 6 months to procure. Basically, so if it is 6 months, I need to actually predict at least about 7 to 8 months in advance that this product is going to fail in this many months time, so that when the actual failure happens, we can replace that product. So that's the whole this thing of having a standard, so that the processes are repeatable. But then you may not find that not all steps will be repeatable in across all the projects, basically. But you will have an arsenal of tools to have to deploy on the data sets, and then do it depending on requirements. You will deploy certain tools, you will not deploy certain tools, or you will do certain steps, or you will not do certain steps. So that is the whole idea behind having a standard, basically. So now once you have the framework for recording the experience, it allows projects to be replicated, basically. So you could use one part of one project in another if required. But in client projects, if you see, there is something called as a non-disclosure agreement that we typically sign. So you would not be able to typically use that across projects, basically. So you will have to develop a new set of code and then put it out there. And then yet to project planning and management is what the standard process does. So it helps you to plan the entire project, execute it, and then finally manage the whole process to execution and deployment, basically. That is what the end product should typically happen. Another very important aspect I want to highlight here is that project planning and management is a very important aspect, because if we don't manage it, project times will move forward. And when it moves forward on the signing of agreements, we normally sign that we have a penalty clause that if it is not given on deadlines, so you will have to pay double the cost of the project back to the client and things like that. Those are penalty clauses that are kept basically in most projects. So company is liable for paying all those things. But if the client is often coming back and saying, I want this change, that change, and all those things, then the project date is re-decided and things like that. So that is managed accordingly. So that is all coming under management. And then there's a common factor for new adapters. Basically, the learning curve for new adapters should be very easy. And that is where we have to demonstrate the maturity of data mining, basically, and reduces the dependence on stars. Basically, you don't have to have a star programmer who does the projects, but even a fresher could basically do this. In order to highlight such a point, in one of one of my friends who was a director had a small budget, and then hiring engineering people for this project was a big pain because of the budgets they had. And what this guy did was he started a new program called an ABC program, And then he trained people from BCom background, BSc background, who knew a little bit of mathematics and statistics to get into data science. And now it is almost about 15 to 16 years now in that company. People who joined with the BSc, BCom have risen to director positions. Basically, so it does not require a star, or you don't have to be an engineer out there. You don't have to be a huge MTech candidate or whatever it is. So you don't have to be dependent on basically the stars, and the learning curve becomes very, very easy when there's a standard process. That's the main objective of the standardization. If you look at the standardization process, the initiative started in the late 1996 for this particular standard by the three veterans of the data mining market. One was the Daimler Chrysler, then which was actually in 96, it was known as the Daimler Benz, and then the SPSS, which was then ISL. Now SPSS is an IBM product. So they have taken over, IBM has been taken over this ISL company, and the was a company called NCR basically. So these three people or these three companies got together and started this standardization process. So they developed and refined these through a series of workshops, which happened from 97 to around 99. And over 300 organizations contributed to this process model. And the first standard came out sometime in 1999 there, and then over 200 members of the CRISP DM SIG-World DM vendors were all part of the whole consortium here. And then there were system suppliers, consultants also here who follow this particular standard in the industry. And then end users basically where a lot of the companies, so it is a B2B, it was a B2B model or whatever you call it from the industry standards basically. So if you look at the CRISP-DM's standard, it's a non-proprietary standard. That means nobody owns the standard. Even though these three people started this whole organization owns the framework. It is not their proprietary right. So anybody can use it across the industry. Any academic institution could use the CRISP-DM framework and implement their projects, whatever it is. It is application by industry neutral. That means as a data scientist, however, we cannot say data is coming from retail, data is coming from time series or seasonal data. We cannot be talking in terms of data coming from the manufacturing industry and things like that. So this all goes to say that the standard can be applied to any industry. Basically now, as I'm talking to you, today I'm working or consulting on a project where I'm working in the on a data set which is basically pertaining to the automobile industry basically. So I don't come from the automobile industry. I have a my background is from computer science, and then specialized in network security, and then moved on to data science as my part of my industry stint. Once I moved to the industry sometime at the age of 46, 47, now already 9 years I'm into the industry basically. And then I have worked on various different domains. I worked on retail industry. I worked on time series data where there are seasonal sales that happens and how to see that sales go up and how sales can be increased and all these type of predictions was what I have done. And I also worked on predictive analytics where it's a totally manufacturing industry where it is a chip manufacturing industry basically. So for which we did this project. So it is application industry neutral standard. You can apply it to any this thing, follow the same steps again and again, and you can get this thing. And we also apply it to examples like, for example, election analysis. That's the best thing people can always relate to, because many of us are interested in knowing who is coming to power, who is going to the opposition, what is happening with some person, whatever it is. So now, from an industry perspective, if election analysis is taken up and then people give exit polls, on the exit polls they say party A is going to win, somebody says party B is going to win, somebody says party C is going to win, and then somebody says there's a hung parliament, there's this thing. And then when the actual result comes, so one of them is very close to the actual result, or he is hit the bullseye basically. Why it is so? When I follow a standard, my main goal of following the standard was to see that the end result, whether A does the analysis or B does the analysis or C does the analysis, should have been the same. But then in real world applications, you will see that there is a difference, which normally comes only after experience, but then people don't identify it and say, I followed the steps of the standard, I have applied my mathematics, this is the right result, is what everybody claims. But then nobody is right or wrong. Basically, they are only 30% far away from the end result, or they're 40% away, 50% away. That's the scenario. There is no right or wrong answers in analysis and data science. Basically, only thing when the actual result comes out, you are far away from it. And the same thing, if I apply it to health industry, for example, and somebody had to be predicted that he has cancer, and I predict he does not have cancer, you can imagine the amount of haywire-ness that can typically happen. Basically, there is a lot of precision that is required in the whole thing. So when I come to these steps, I will tell you where exactly the whole crux lies, why exactly people go wrong, and things like that. It is also tool neutral. I could use any tool that I want. CRISP-DM does not state that you have to use a specific tool. You could be using Python, you could be using R, you could be using SAS, you could be using any of those tools available in the market, basically. And then you focus on business issues as well as technical analysis, depending on the data that you typically have. So since it is application and industry neutral, you could do any type of analysis of the data based on whatever is being looked for in a particular data set. Then you have the framework for guidance. Basically, you look forward for some guidance when you are doing the whole process, basically. And then there are experience-based templates already available, basically, into which you can substitute things and generate a lot of reports and things like that, which normally is, again, these templates are also openly available. There are some companies which provide it at a small cost. So it all depends on what type of reporting you need to do and what is the requirement at the end client. So when we come to the overview here, you can understand by just looking at this diagram, what are the steps we are doing. The business understanding or the domain understanding has to be done, because as a data scientist or as an analyst, I am not well versed with all the domains, because we come from a particular background. Say we come from computer science, or we come from data science, or we come from this management, whatever it is. We are specific to one area, basically, and we know that area to a certain extent, basically, and then we build on that. So now if there is a new thing, I told you that I've I am doing a present project on automobile industry, for example. I need to understand the ins and outs of the automobile industry, and it takes at least about, depending on the time of the project that is there, I would spend at least a week time understanding the domain. If it is a 1 week project, then I don't have time at all, basically. So what we normally do is we spend the first 2-3 days understanding the domain, and then whatever data has been given by the client is what is the understanding we would do to make an initial analysis. Understanding the data would give me a fair sense. Supposing in the sense that if I have data that is pertaining to diabetes, for example, I draw the normal distribution curve and then see how the distribution of data is. If it is skewed towards the left, I already conclude, or I already reach a conclusion in my mind that there are people with more of a diabetes. If it is a right skewed, then I presume that it is people who are having less diabetes. If it is normally distributed, then I presume that there are about 50 to 50% or 60% of people who don't have diabetes, about 40 or 50% of people are having diabetes, is something I would presume based on the understanding of my data there. And then based on the understanding that I get out of this data, I needed to prepare in a particular way so that I can give it to my machine learning model or my deep learning model or whatever you are putting it into, basically. So there could be this step of a domain understanding. There's a step of a data understanding. The step of data preparation makes all the difference. This is where people can basically go haywire or go away from what the actual result is there in the data, basically. So that is where the whole crux of the problem lies. Another very important aspect that you should understand is whatever data is given to you is what has happened in the past. It is a historical data that has come in, and then you need to go back and say how we are going to predict for new values. For example, let us say there is a car launch very recently, but we have built a model, say about 3-4 months ago, we have built a model which predicts, say, mileage of cars, for example. So I have understood the data, I have prepared the pattern, I have applied the model, I have evaluated the model, I already deployed the model also. So when the deployment comes, I will go there, I will just give the new values that have to be given to the model, and then it will predict what would be the mileage of the new car, basically. So that is what we are going to do in the whole process. But the answer that I want to answer is these 3 steps make the whole difference in either making your result close to the actual fact or away from the actual fact. Because I would not really say that you are making a mistake. Basically, you are just following blindly the steps, and then finally you are saying this is the result, basically. Since we many of us would not even understand why we are doing this entire process if we are not part of the industry process, basically. So that is where the whole crux lies. So when I'm doing my data understanding, a lot of things depend on my perceptions. A lot of things depend on my subconscious mind. Whenever I'm looking for information, my mind watches for a particular set of this thing, because that is how the mind has been trained, basically. So the moment I see only those type of patterns, I apply those type of transformations on the data that is that I presume to be right, and then the whole data preparation has actually gone for a toss. So that means we need to be away from our own perceptions. We need to be away from our own subconscious mind, what it is telling us. We have to actually look into what exactly is there in the data, understand the data, and that is one of the reasons why when understanding the data, we would also do what is called as a ED analysis. Exploratory data analysis is what we would typically do. And then look at these graphs. Basically, if you see, pictures talk a lot more than numbers. So basically, these numbers that I'm talking about in real-time project may be anywhere between 10,000 to even 5 lakhs. So there are even big data projects where data is in terms of anywhere between 1 to almost about 10 TB of data, which we handle in the industry, basically with a lot of tools, which you might have heard of. So the moment you get into big data, I cannot be doing many of my workings on a simple laptop. Basically, I need to get connected to a cloud where these data exists either on AWS, Redshift, Snowflake, Big Data Query. There are a lot of such databases available. So depending on what the client wants, we would do that. So these two steps take the major part of the project. Basically, it takes nearly about 90% of your time to prepare the data, basically, and then fit the model fitting is part of the tool. So all you have to do is take the prepared data, split it up into the standard normally we follow is 70-30, but then then depending on the requirement and the accuracy that you get at the end at the evaluation, we can always go back, resplit the data into 60-40, or we follow even 80-20. Depends on how the historical data that we have got. So by trial and error method in the evaluation, we will be able to go back and rework on certain transformations and also the splitting of data in the data preparation step. So that is where this is where the whole crux of being close to the result or away from the result lies, because it basically depends a lot on the perception and the subconscious inherent things that you already know, based on which you are going to look at the data. Let me give you a very simple example why this happens. Supposing, let me say, I kept my table very messy, for example, and then I have put the car keys there, and then I'm trying to search those keys on the table. Now, my mind is somewhere else. My mind is worried whether I have lost the key, and I'm searching the whole messy table basically, and I'm not able to see the keys. But somebody else walks in there who's there in a cool mind setup. He just checks out a couple of things, and then he says the car key is here. Basically, many a time, I don't know whether it has happened to you, but many a time it has happened to me, because many of my papers lie scattered on my table and things like that. And then my wife comes and picks it up for me, basically. So that is how you tend to look at only those things what your mind perceives, basically. So whatever we have been doing for years together will all have a bias on what analysis or whatever transformation we are going to do on the data. So this is where we need to relearn to be unbiased in our assessments, and then prepare the data. Then you will be very close to the actual result, or you will hit the bullseye of whatever the result is. Best example I can give you is that of the meteorological department. Basically, they say it is going to rain at 3 o'clock, and you see many a time that it does not rain. So that is where this thing, there's a historical data that they have taken on, they have made a prediction and they say that there is going to be rain, but then there is no rain. Or the rain instead of 3 o'clock happens at 2:30 basically. So the accuracy of the data would come from these two steps, and this takes some time to settle down because you need to put all your other thinkings away, get into the actual domain of the data, and then think as a domain expert. And only then this becomes possible, basically. And that is the main reason why many predictions are away from the actual result. That is why exit polls are far away from the actual result that comes on election day, basically. So this is what we have to remember. Most of us may be under the idea that all this is all, most of it is all mathematical. So 1 plus 1 is equal to 2. So this is what it is. But that is not the case. Basically, these three steps involve a lot of insights to be done before you actually go into the modeling. Modeling is just you give the split data and then the model is going to say what is it basically. So that, and then you evaluate based on whatever accuracies you want to get. If it is classification, if it is clustering, we basically, if it is classification, we look at accuracy. Then if it is clustering, we have a whole set of other evaluation parameters. And then if it is a regression, we normally do something called as the correlation in statistics. We use it from there, and then we say whatever we have predicted and whatever was got historically, if they are very close, then we say that the prediction is pretty decent. That's how we would do it in regression, basically. And another very important aspect to remember from a perspective of saying that we have done the right this thing is to look at a lot of performance measures across, and then say that the model is working well, the model is not working well. In industry parlance, what we do is when we are modeling, we will apply all the algorithms that are typically available, and then we would select the one that is giving us the best output for the data that we have prepared. And not always does your evaluation map to real-time data. What you have to remember is whatever client is given you here in the data is sample data. They never share the real-time data, basically, because most of this data are all proprietary data, and then if it goes into other companies' hands, it can be there can be a havoc, basically. Even though there is an NDA, we all know how it works in India, but then in countries like US and all, the law systems are very very rigid and things like that. And when an NDA breach happens, people can sue. I don't know if people have read the news very shortly. A couple of days back, one of the employees from IBM moved to Accenture, and since it is a competitor company, the agreement had told that you cannot join the competitor for the next 2 to 3 years after you have left the company. And this lady went ahead and did it. And then there is a case in the court in the US claiming for almost about $5 million as compensation for doing this, basically. For maybe when you join the competitor, you may disclose what was happening there, whatever it is. So all these things is very foolproofly taken care in the US, but here in India, we don't bother. Let him go. That's how we treat it in the sense of the term. So that's a different part of the story. But then when we are evaluating, we may be again wrong, basically. That is another very important aspect I want you to remember. Say, I will give you a very real-time example, basically. I was talking about this predictive analytics that we did for this client, basically. And then when the data was given to us, sample data, we were getting about 95% results, and that is what we had to give in 8 weeks' time. And as per the agreement, it's fine. But when these people started working on the real-time data, it started giving 27%. And when it gave 27%, these guys started fuming there in the other side. The client started fuming. And then the project came back, and then we did an analysis, and then it was found out that the statistician who was part of this project basically had not taken care of the multicollinearity problem when preparing the data there. That was the first step, or the first biggest mistake. And then when the modeling was being done, actually, we also do what is called as elimination of the insignificant variables using the p-values, basically. And one of the Python packages was actually giving p-values in the range of about 1 lakh point something. So you know that from statistics, p-values are always in the range of 0 point something and things like that. So while doing the evaluation, the guy who looked at only the parameters that came from the model and did not observe the statistical mistake that had typically happened. So when we retraced the steps, we found out that these two things have made the whole difference, basically. So we went and saw that the Python maturity was not there. So the solution that I implemented was to put a R in the background, because Python is a glue language out there. So you glue the Python, the R in the background, and then from front end Python, you transfer this data into R, get the p-values into the whole thing, then start eliminating the insignificant variables, and then do the whole process, basically. And Python, I don't have to do it step by step as in R, but even though it internally does all these steps, basically, of eliminating the insignificant variable based on the p-value. So once this was done, we were getting only an accuracy of about 92% now. And then when it was given to the client, then you can see that the percentage of accuracy rose to around 90% for the real-time data. So not always you will be having the final result for deployment once you have completed the project. So there may be a couple of retakes that you take, feedbacks that you take from the client, and then go back and fix those problems also. And those fixing of problems takes couple of weeks more, or a couple of months more also, basically, because there can be solutions, there can be problems that you will have to overcome and then do it. Like in this case, the Python was creating a lot of trouble, so we had to go and rework with R in the background and do these things basically in real time. And you don't have time to think, basically, but you will have to think at that moment and then do it. So that's how the whole process happens. And then finally, once all this green signal comes, everything comes, then you go and deploy it on the server, basically, or on a cloud for the client, and then he starts using the whole package out there. That's the identification that you need to do, basically. Clear? These steps are clear. So deployment is another this thing there. The deployment usually many a time we need to develop the UI and UX also. You'll have to develop the front end also basically there. So that means you need to know web technologies also basically if you are the lone person doing the entire project. But then as a team, there will be a person from web technologies who can take care of that if you are working in a team. So in my case, I work as a single-handed this thing. So I do right from understanding the business to even deploying at the other end, basically. So this is what the whole process needs to happen, basically. So these are the steps or the background that I want you to understand before we get into the whole crux of this thing. So in the business understanding, basically we do what is the project objectives and requirements, understanding it from a domain perspective, data mining problem. Does the definition of this particular project fit into a data mining problem or not, and things like that. In the understanding data, you normally do initial data collection and familiarization. Basically, in most of the cases, client would give you the data, but there may be scenarios where you collect the data also. This data collection may be through questionnaires, it can be through interviews that you do to the client. A lot of things can come into place. And data can also be collected on the move, basically. Supposing there's a showroom, the billing data, or the sales officer giving sales data, basically collects on the move. Every day evening he updates it, and then when he is entering, one of them doesn't enter, one guy has missed some value there. So there could be a lot of data quality problems that you identify also while you are looking at the second step of data understanding. So data that you get may not always be of quality, basically. So you may have to first work on the quality of the data, then go and go prepare the whole data process, basically. Then data preparation, how exactly it frets, and then data transformation you do. You can be doing a lot of recoding in the data, reshaping of the data, and things like that. You would require a lot of cleaning of the data. Basically, there may be a lot of missing values, which statistically may not be possible to be treated. Those are things that I would like to clean or drop it out from the data set and then do it. In one of the projects which we were doing for one of the clients, basically this person had given about 9,000 data points, and then 2,000 had missing values, so that we have actually left out the 2,000 there, and then only with 7,000 data points we got an accuracy of close to around 97%, and then we went for the presentation. But then the CEO here was a little hesitant and things like that. So he said, no, all the 9,000 data points you have to take. So, okay, let's do it. And then we reworked on cleaning the whole data set. And then the whole data set gave us a result of about 37%, basically, in terms of the accuracy. So this model was not a good fit at all. So it is not always that larger data sets will yield me good results, basically. And data of quality only can actually give me the actual results that I am typically looking for. Another very important aspect to understand here is there may be scenarios when the client says, I want to showcase this type of the product on the market. For example, let us say there is an advertisement that is coming from Horlicks, there's an advertisement coming from Boost, there's an advertisement coming from other cereals, basically. So there was a point of time when people were advertising in terms of saying 9 out of 10 people are using my product, and everybody was claiming that, basically. How is it so? Now the data collector actually makes a data manipulation. Most of these serials, thousands of people are working in that organization. From a statistical point of view, if I have about 60 samples or 60 data points, it is fair enough to be a sample basically. So I call 60 people, 6 people, I ask them to write, I don't use this product. 54 people, I ask them to write, I use the product. And then I make an analysis and say that 9 out of 10 people are using the product. And statistics permits the outcome from a sample to be extrapolated to the population, basically. So from a statistical point of view, this is correct. But then, from a business perspective, everybody of us know that this is a manipulation being done. So even though we are doing data understanding, data preparation, there may be cases where you are actually have to do such type of management to see that the client is happy at times. It is up to you to say that I want to take up such a project or not. That's again a choice, basically. So data cleaning is a very important aspect. So the more the data from a statistical point of view, yes, it should give me better accuracy. Basically, the more data the learning, the machine learning algorithm or the deep learning algorithm learns, it will give me better results, no doubt. But then the data has to be of quality. That is the basic understanding that I have to do. Then I apply my modeling technique. You select the selection, application, parameters, calibration, and things like that. Usually in the industry, we don't have time basically. So what we normally do is on the same program, we apply all the models in one shot. We get the accuracy, whichever is giving the highest accuracy. We pick up that model and then say to the client that this is the best model and things like that. And then in the evaluation, we would look at the whether the business objective for which this entire project was started is achieved or not, and then issues the achievement evaluation. If it has achieved, then we go to the deployment where we push it onto the client testing. Nowadays, I see many of the people who don't want to share data usually put it into the cloud and then share it with us to do the project. And then there is an NDA which very specifically says that we cannot copy data from here or you cannot remove it from that cloud or server, and then you deploy the whole thing there, and once the project evaluation is done and you give a clean sheet, the whole this thing infrastructure is transferred to them. So like in the olden days, people don't travel to do deployment in today's world. Basically sitting at one place, all these steps are completed, and if there is a maintenance issue, they give you again authorization to get into the cloud, and then you do the maintenance part of it also if you are contracted for maintenance. So this is the whole process that we will normally do. Let me skip let me skip some of these slides here and come forward to things that I really want to highlight. Another very important aspect that we normally do in the data preparation part of it is applying standardization and normalization, basically, because one of the columns, if it is having higher level of values and another one is having smaller values, it can create a bias in the whole analysis basically. So we normally standardize it maybe using a Z formula, or we go for normalization if we very specifically want it in a specific range. Let me illustrate this with a very simple example so that it is easy to understand out there. I hope you are able to see this Excel sheet that I have just opened here. This is a data that is pertaining to shark attacks by country. So here there are three different countries data that we are typically having there, and then you can see that the highest value that we are having in the record for USA is about 232 here. I've taken basically a very small data to illustrate this point. And then you can see Australia, the highest is around 94 out there. And then if you look at South Africa, the highest value is around 68 there. So you can see that this 232 is larger in comparison to 94 and 68. So it could create a bias. So when I draw the radar chart for this data, you can see how the value distribution is basically there. So for Australia and for South Africa, it seems to be very, very less basically. But then if you take a scale of say 100, then this is 80, this is for example 60, then this is 40, and then this is around say 20. So if that is going to be the type of values, you can see where exactly all the values are being concentrated. And to understand this figure is slightly difficult. So what I did was, I did a small transformation here, or applied a small normalization on the data there. I use this formula. I said all the values need to be converted from 1 to 100 basically. So I said 1 plus the minimum divided by maximum minus minimum is what is the normalization formula. To that I just added this part where I said 1 plus multiplied by the 99. So that I get values between 1 and 100 basically. So if you look at the values and now the values predominantly from the top, 28 has become 1.5, 27 has become 1, and things like that. So this is the normalization I have applied to the data there. And based on that, I'm able to now understand that all the values, maximum values are between 100 now. All the three columns, it is 100. So now comparing the data from this graph between the three countries becomes extremely easy for me now. And that is the type of transformation I would apply depending on what is the type of data set that typically comes in. So this is the understanding that we need to do in order to go and say whether I will go for a normalization or I will go for a standardization using the Z-score. Because when you put the Z-score, the values will be between either -1 to +1 or 0 to 1, depending on the type of values that you have in the data columns, basically. So that is the identification that you need to do when we are talking in terms of putting the standardization and normalization in place. So what exactly is this? Feature scaling is one of the most important data pre-processing steps in machine learning. So algorithms that compute the distance between the features are biased towards a numerically larger values. Say, for example, I want to make a prediction between the years of experience of an employee to the salary he gets. And based on the experience, I want to predict his salary. So you can imagine that the salary column is going to be in lakhs, while the age, the experience column will always be between, say, anywhere between 0 to say about 25 or 30 or 35 or 40, based on the total number of years of experience that a company supports. You would have that type of data basically. So the experience column is always lower, while the salary will be column would be in lakhs, and then there is a clash between the two. So those are points of time when I want to put this data into a normalized form and then do the entire transformation and then apply the algorithm to make the prediction of whatever problem I'm trying to solve on that particular data set basically. We could also use tree-based algorithms which are fairly insensitive to all these scales of features. For example, algorithms like your decision tree, your random forest, most of the neural networks, we would never do such type of data transformations basically, but it would actually create a scenario where you are able to do a lot of other things out there. So these are some feature scaling techniques such as normalization and standardization that are the most popular and at the same time the most confusing ones basically. So normally if instead of going for all these things, if we go for algorithms where it is where these algorithms are sturdy or robust enough to take care of all these things, then it is fine. Mostly algorithms like the KNN, the SVM and all these things, we will not even be treating outliers basically. Outliers is another very important aspect when it comes to data quality out there basically. So we need to be extremely careful. So that is the whole this thing. So if you look at the standard normalization formula, you will use the min max. This is the formula for that, and then you will normalize the data there basically. That's how the whole this thing comes through. And then z-score normalization is something that we would apply to the data where it is. Where it is actually values required between -1 to 1 or 0 to 1, we would apply this type of formulas basically. So that is how this thing is. So standardization can be helpful in cases where the data follows a Gaussian distribution or it is normally distributed, and that is why we try to actually look at the mean and median scores of a particular column. When we look at the mean and median value, if it is equal, it is a normally distributed data. Where the median is greater and where the mean is actually smaller, it is left skewed data is what we presume, which means that it is on the left side of the graph. and then where the mean is less and the mean is more and the median is less, it will be on the right hand side of the bell curve basically. So it helps me to understand what is the whole perspective out there. And then geometrically speaking, it translates the data to the mean vector of original data to the origin and squishes or expands the points if the standard deviation is 1 respectively. So we can see that we are just changing the mean and the standard deviation to standard normal distribution, which will still be normal. Thus the shape of the distribution would not be affected when you are doing a standardization or a normalization process. Basically, the content that is there with us on the data should not distort basically from whatever original distribution it was in to whatever new distribution. That should not happen. So when I apply standardization or normalization, I should see to it, it is seen that if you are applying the mean or the standard deviation in case of the standardization or the min or the maximum values, it will not hurt the distribution basically. So standardization does not get affected by outliers because there is no predefined range of transform to or the transformed feature basically. Only if it is in the original form, then we have the IQR, and then we calculate the statistical maximum and statistical minimum in order to go and say that points above the statistical maximum and below the statistical minimum are all points of outliers basically. But when the standardization or the normalization is already put in place, when the standardization is put in place, then we do not then there is no method by which the outlier transformations can be basically done. So this is the remembrance that we need to do. So all this can be applied by using what is called as a pre-processing dot scale function from the sklearn data package there. So you could basically apply these scales or normalizations in the code basically. So pre-processing dot scale will do a scaling, and then there are this thing for fitting this thing standard scalar, and then you fit this transform there and things like that. So that you do from the code level basically, and then when you do this min max scalar, you would normally be doing the normalization basically on the data set that you are taking into consideration there. Next, coming to the missing data again basically. So because most of the machine learning language models that you want to basically use will provide an error if you basically pass NA and values into it basically. So the easiest way is to just fill them up with zeros so that they don't make differences. And another very important aspect is to remember from the statistical point of view, you could apply the mean, the median, the mode, you could apply the statistical maximum, statistical minimum, all these things basically. I prefer applying only the mean because it doesn't create a major problem, because mean is only a average of the whole data set basically, so it does not majorly affect. But median is the centermost value of the data set, so you would see that the centermost value keeps repeating. So when the value of a particular data point keeps increasing in the data set, it will create a bias in the analysis. So I normally don't prefer that. And then the statistical minimum and maximum are again values that are the values which are usually inside or outside the data set. So if it is inside the data set, it will increase the number of data points. Even if it is outside the data set, then also it will still increase the data point. data points, which will again lead to a specific bias out there when you are doing the analysis. So typically, I do not prefer using these things even statistically if it is permitted, basically in real time, so that all these type of small things that you take care will go a long way in seeing that you hit the bull's eye when the actual results are given, basically. So that is where the model accuracy will significantly increase when there is data of quality. So filling missing values, there are many methods. As I said, you can fill it with mean, median, mode, all these things basically. For choosing the best method, you need to understand the type of missing value there and its a significance. One thing to remember is if it is a numerical data that is typically missing, then it is easy to do some type of treatment. But if it is a statistic, if it is a character based data, say somebody's name is missing, at best I can do is just put XYZ there and then say, take the analysis. But then when I actually transform, what would typically happen is the character data has to be basically transformed into numerical. So we would use a function called as dummies there, basically get underscore dummies in Python, which would actually create a matrix of ones and zeros, basically depending on number of unique values in a particular column and things like that. But a name column will not make that much of a difference, basically. So most of the time, some of these columns are removed basically because of their insignificance, and then which does not address my objective of the problem. Then I would remove such columns basically, and then go through the analysis. So before you start filling, deleting, data has to be completely understood. That is what I was trying to tell in the second step. So that makes a lot of difference. If you have not understood the domain, ultimately understanding what exactly may be missing, what exactly is the treatment that we have to do will be out of place, basically. So how to handle missing values in Python is something that we could look at. So NaN is what will be the representation when it is a numeric column out there. And then there could be null values, none in the data set and things like that. And df.info, the function can be used to give information about the data set. So this will provide you with the column names along with the number of null values and so on. So you find the number of null values and then you decide whether to treat or not to treat. Usually there is one basic standard that we normally follow, but from a statistical point of view also it is fair enough. See, most of these algorithms, especially the logistic regression, gives you accurate results when you have 1,000 data points or more, basically. And most classification algorithms will work with any size of a data, basically. But then when you want to look at more accurate, precise data, at least 1,000 data points should be there on your data set for most of these algorithms. And when I say more than 1,000 data points, if I have more than 1,000 data points and then above 1,000 there are a few missing values, I would rather directly delete this in real time and then go and fit the model and do the whole process of, instead of going and treating the data, looking at the outliers and things like that, I would directly go and analyze, because in real time, most of the time, the deadlines are very, very short. There are times when I have to take up a project and within 2-3 days, I have to give it. I remember a scenario when I had just moved into the industry. Prototypes are usually done on Excel, basically, and I was not very much aware of these protocols as a fresher when I went in at the age of 45, 46 there. My boss said, you take up the proto meeting and then you proceed. Then I went ahead and then I said I will make a prototype in Python and give it to the client. And then I took about a couple of days, even though I had given 3 days as the deadline. I did it on the second day, second half, and then we had a meeting with the client. And my boss was there in the meeting, and then he said, the client said, all this is fine, boss. My idea of doing this project is already gone. So that was a hell of a shocker for me. And then once the meeting was over, then there was a lamp blasting in my boss's room. I got, and then he said, "This is not the way the industry functions, boss. If you don't learn the nuances of the industry, you can better leave." That was the thing on my first call that I had. And then after some time, when he cooled down, he called me back and he said, usually prototypes are done within a couple of hours on Excel, and then you showcase the problem, and then the project comes through. That is what you have to do. I can understand your scenario, but then please do it the next time, he said. And then we closed for that day. 2 days later, I got another meeting where I had to showcase this prototype. So I said I will get back in a couple of hours. I did a prototype in Excel, and then that project came through, and that project was almost a 1 billion project for the company. So immediately the boss called and said, "Oh, fine. Oh, so if it works, you are a guy, you are a nice guy. If it does not work, you get all the lamp blasting." That is how the industry, most of the industry works basically, because there's a lot of revenue that is looked at, revenue generation that is looked at out of you month on month, year on year, basically. And if you are a revenue generator, then the pink slips normally don't come to you, basically. If you are not a revenue generator, then the pink slips are on. That's how the whole scenario is all about. Um, so what you need to understand is it's a fast world and everybody wants solutions in a jiffy, and that is the pace at which the industry is working. So you need to adapt to such scenarios, basically, to work at pace, to work at ease, and be deployable on projects, basically, by the end of the program. So that is what you need to look at. And if you look at missing value, you try to understand the data, how many, what type of data is there. Not null indicates that you could have null values out there, and it is also showcasing a number of null values in the data set. It is showcasing the data type and so forth. So you can understand all these things. So you could also see, check if there are some null values or not in the data set. Then age column is having the maximum out there. The rest of them are having zeros, typically. So you are summing them up and putting them out there in each of those columns, basically. Normally, another thing, very important aspect I want to highlight. Let me see whether this particular data set is open. Yeah, it's open. No, not this one. Yeah, this is the one that I want to showcase. So let me select the entire, oh, will not work from here. So my license is not there. Check out. Okay, you can see that I already applied a filter here. Hope that answers your question out there. And then I look at these values here, basically. So you can see that there is no missing value in this particular column. If it is a missing value, it will be displayed as a blank, basically. So that is where the whole indication will be that there is missing value there. Then only these values are there, so there's no missing value in the data set. This is how we find basically using Excel. The initial data understanding is done like this. So you can see here also, I don't have any problem in the displacement column, but here I want you to observe very, very carefully here. So if I come to the last here, this is what I'm seeing. So that means there is some missing value here. And another very important aspect I want you to think is, since there is a question mark, this is saved as a character data out there. So in order to showcase that, let me show you a very simple, with that particular data set, let me show you the information here. So when the df.info is executed, this will be my specific output. So when I look at the horsepower column, you can see that it is stored as, it will either display as an object or as a category in terms of Python, basically. So here, since this is an object, you can understand that horsepower has been saved as a character column because the problem is in the data set that I'm highlighting here. And that is, you have a question mark out here in the last this thing. There must be about 6 such records in this data set, basically. So if you want to view that, what I can do is I can deselect all the other things and then select only this one and then say apply. So you can see these are the 6 records: record number 34, record number 128, 332, 338, 356, and 376 are the records at which question mark has been saved. And always a character will always be displayed on the left hand, the right hand side of the cell there. Left hand side, the numerals will be displayed. You can see that identify this by just looking at the data set, by just looking at whether information is saved on the right side of the cell or on the left side of the cell. Immediately you will identify. You can see here the character data being saved on the right hand side of that cell, while the numerals are saved on the left hand side of the cell, basically. So this is the type of understanding that you have to get through in the data set. So now what amount of missing value treatment I will apply here, it will not work because it does not recognize. What am I trying to say in this case? The point that I want to drive here is, whenever you are talking in terms of a missing value, it is in Python going to go and check and say whether it is NaN, whether it is a null value. Question mark is not a null value. Question mark is not a null value. So you should not actually be carried away by just running a NaN value and saying that there was no missing value in this particular data set. But then when I have understood the data set, I found out that there are question marks in that particular column. So I have to go and first fix that. basically. So I will go and find first initially when you run this code, it is giving me an empty series saying that there is no missing value. So if you just get carried away by this output, your whole analysis will go for a toss when the actual analysis will start happening. Because when it enters your algorithm, horsepower column, which is numeric, it will be still in character column there. So which does not help me in my basic analysis out there. So once I have understood the data set, once I have understood what are the values present there, once I have understood what type of values are there in the data set, then I go and make a replacement here. Say question marks should be replaced as NANs here. The moment I do that, it will automatically be turned to numeric, basically, because this was the one that is typically giving me that character representation. So the moment I change that to NAN does not exist in character. So automatically it will come here. So basically df dot is now gives me 6 values here. That should be the thing. And then you go and change the type to which you want to save it. You can either set it as numeric, float, whatever it is. Then you run the df.info. Then you go and do the df.info there. So you will be able to identify. Just give me a moment there. Okay. So that is how you would do the missing value treatment out here. Then once I'm going for the treatment, once that this thing has been changed to NA in this case here, once you have replaced the question mark with the NANs there, you can go ahead and then replace the value. So I can just say the data frame name dot fill NA with the mean of that particular column. So I can just do that. I did this treatment very specifically in this data set because if you see here, if you look at this column here, you can see all the columns having 398 values basically. So there is actually, in case there is no missing value, if you look at it from this point of view also, basically. So, but here, this is inclusive of the question marks because it is a character, it is already counted basically. So you have to be careful with such things when you are actually reading the data. And then you can observe the values here. When you run this summary command here, basically the summary command here, describe is what we use, df.describe. And then once we do that, we get all the numerical columns will give the mean, standard deviation, minimum, the first quartile, second quartile, third quartile, maximum. So this minimum and maximum value indicates the value in that particular column basically. So in that particular column, now if I look at the mean value and the median value, which is nothing but this percentage value here. So you can say here, this is 23.48. while 50% of the median value is showing 23 point something, 23.48 and 23.0. I consider it to be very, very close. So it is almost normal in this case. Here in the second column, if you look at it, is 5.45 and 4, slightly away. But then I would take it as, since the median value is less, this is right skewed basically. It is there on the right hand side of the graph of the normal bell curve basically. Slightly it is pushed because the values are decently close again. So here you can see there's a large difference. So the mean value is 193, while the median value is 148 in this data set. So this is a large difference where the mean is greater and the median is lower. If the mean is greater and the median is lower, it is left skewed. This is also left skewed actually, not the right skewed. And then this is a character column out there basically. Since this is a character column, not a character column, actually this is not actually giving the right result in this case. Anyways, it will give you the mean and median. So what observation we do with this data is to identify the spread of the data basically. That is the identification that we have to do here. Okay, that is before changing the data type. So NAN is actually right there. So then you can go and make the missing value treatment there, and then you could do the whole processing of preparing the data out there. The next step we normally follow is to go ahead and look at the treatment of the character column into numeric basically. So in this case, we are trying to actually split the car names. If you look at the data set, you will understand basically that if you see here in this thing, there are multiple this thing, car names and car company name, and then followed by the model. And there are some numbers also basically to indicate that this thing. There are 4 different this thing. If you look at this Buick Estate Wagon SW, there are 4. And then here Toyota Corona Mark II, so on. So you find different values. So now, another very important aspect that we need to understand here from this data set is that I will always be able to map to what type of a car based on the cylinder. If it is a 3-cylinder car, then we are looking at small cars. 4 is also a type of small car. 5, 6, and 8, and whatever we have in this data set are considered to be the larger cars or the SUVs or whatever you actually define. So it is fair enough to have only the company names and then map it to its particular model. Another very important aspect in the automobile industry that you should remember is on my own same company, I would not have a competitor for the same cylinder of cars unless until it is slightly, there are some featuring differences and things like that. So if you find a 3-cylinder car, you will normally, at least now in the Maruti, you would typically find something like the Alto 800 and the Alto 1000 series of cars basically are in the 3-cylinder car segment, while 4-cylinder cars, which are in the range of about 1000cc cars and things like that. And then you can find the 6 and the 8, the larger cars, especially the in the 8, you can find Scorpio, all these bigger cars basically. So it is fair enough to have only the company names and remap them at the end basically to make the data transformation basically. So I'm going to split the data in this case basically. So I am splitting the data and only retaining the car names basically. So once that transformation is done, there are different repetitions. There are some spelling mistakes that are there that was identified, that is identified on this data set. So this will we will go and treat these things and say that this is the value that has to be followed, so that it comes under one unique company basically. Else this will be displayed as multiple companies on your data set, and the analysis may go higher. Basically, these two things will be considered differently. Mazda and Mazda are the same, but spelling mistake. Mercedes and Mercedes Benz, and then VW, Volkswagen, all these things basically, and then Ford, Capri, Mercury, and all these things. High, Honda, and all these things basically. So that's the whole process that we normally do to rectify the names. And once you have that, you will find that there are 27 unique values in this data set. That means cars of 27 different companies are there. So I can use to map to predict the values. This is a project where we had done to actually predict the mileage of cars basically. Nothing to do with any company data, but this was some data that we have collected online and then try to put in place basically. And then the Ford basically, and then there is Ford is the highest number of times it is occurring in this whole data set. Out of 398, there are 63 records pertaining to Ford out there. So in order to see that there are no outliers out there, basically, we would draw the box plot basically out there. And once we see if there are outliers, then there will be some points that are coming above this. This is a representation where the lower side of the rectangle will be represented as Q1. The center bar will be represented as Q2. The higher bar here in the rectangle will be represented as Q3. This is my statistical maximum. The one at the bottom that you see here is the statistical minimum there. So that is the identification that we need to do. That's the first step. So points that are above my statistical maximum and below my statistical minimum are the points which are actually outliers. So for treating the outlier, we write a simple function here which can take care of the whole process there. So for doing the outlier treatment here, there's a small function that we have written here. So you can say define out is the name of the function that we are giving, and data is the entire data column which is going to be pushed from there basically from below the code. So first is to see that we want a sorted list, because without a sorted list I cannot find the 50th or the median. I cannot find Q1 and Q2. It is only done in a sorted list. So I'm sorting the data first. And then I'm trying to find Q1 and Q3, which is my requirement, basically. And then Q1 and Q3 is what I try to find using this function called np.percentile. What you need to identify from the Python coding is that I have taken NumPy package, which is a built-in package, and I am giving an alias name as np there, and then I am referring to this particular package inside which there is a percentile function which would give me this particular this thing. I could also say Q1, Q2, Q3 and say data, 25, 50, 75. I will still get the result. But in this case, I'm interested in finding the statistical maximum and the statistical minimum. So I'm just calculating the Q1 and Q3 there. I find the interquartile range is equal to Q3 minus Q1 is what we calculate from statistics. And then the statistical minimum formula is given as Q1 minus 1.5 into IQR. And then the statistical minimum is given by Q3 plus 1.5 into IQR. IQR is this that we have calculated here. So I find the statistical minimum and the statistical maximum and put it into variables LB and UB. So now I'm doing a treatment here in this step. I do a treatment of the outlier. If the value that is there in the data set is greater than the statistical maximum, then I'm replacing it with the statistical maximum. And then if there is a statistical minimum value that is below the statistical minimum, then I'm replacing it with the statistical minimum itself, basically, and then returning the value. So outliers have to be taken care of so that it does not distort the whole analysis. But again, it depends on the type of machine learning algorithm that you are going to apply, and then go through the whole process out there. So in order to do that, what we normally do is, once we have found that there is a outlier out there, I would use or call the outlier and send this particular column to it, and then the function will execute and remove the outliers out there in the whole code, in the whole column, and then return it to me. And then I'm plotting it, and then initially I may get the points out there, but then after the outlier treatment, I will not get any points that is above and below the statistical maximum and minimum. So this is how outlier treatment can be basically done. So in missing value that we were discussing, we are deleting either we are deleting the columns with the missing value itself. If there is a column which is having most of the lines in that column or rows is the thing, we normally delete it. We can delete the rows of the missing value, number of rows can be deleted, and then filling the missing data with a value or basically an imputation out there by giving a mean value or a median value. That is the type of imputation that we are talking about. Imputation with an additional column can also be done. And then filling with regression model, previous regression model results also. Sometimes we use it depending on the application, basically. So normally it is all the statistical values with which missing value is normally treated. So from a coding point of view, you can use this simple imputer, and then say strategy is equal to mean, median, mode, whatever it is, and then do it basically from the Python point of view. This particular package is there inside the sk9 learn.impute package. Inside that, we can to differentiate, we could also call the simple imputer as a module basically there. You can see here how we actually we could now, if we are using a linear regression out there, how we are applying the whole process there. So you can see that the model is being applied for the trained data set. I said we split it into two. So the larger set is called as a training data set with which the machine learning algorithm or the deep learning algorithm is going to be trained, while the rest of it will be used during the evaluation to see the validity of our results to the mapping outcome that we are trying to see. Just give me a minute. Hello. Can I call you back? I'm in a meeting. Thanks. So the next one that we could typically see is the recoding of data basically there. So recoding variables is sometimes necessary if you want to create new variable groups. Supposing I have an employee data set and then I want to classify and make analysis of how many people are there in the low income group, in the middle income group, in the high income group. I can transform by giving a specific condition that say from this range to this range, it will be low income group. From this range to this range, it will be middle income group. And then in this thing, I make it into a categorical variable saying this is LIG, this is HIG, this is MIG, something like that. And then I transform the numerical value in the salary column into a column that is of interest to me in the analysis. So that is called as recoding of data. That means from one form, you are transforming it into a form of your requirement out there. So that is the type of understanding that we need to have when we apply recoding to a data. For example, say there's a simple variable called the village hyphen town, for example, whether it is a village or a city is what we want to indicate basically. And then the categorical variable of city and village is the values there in that particular this thing there. So I would like to have a count of how many city and how many villages are there in the data set. So how do I recode this? So however, we want the values to reflect variable names that have data values of village and town. So to do this, we can create a function and then apply it to the variable to recode all the values that are city and to town. So city can be represented say as 1, town can be represented as 0 and so on. So I can make a recoding out there basically, and a new variable that contains a category will represent the groupings of the age out there basically. So that way I can keep changing this thing. Say for example, I want to change here series of the age group there. So I can say for example 15 to 19 less than this one, this is returned series of less than 25. So each age group can be defined there. So how many values are there in each of those groups is what we are trying to find. So from 15 to 19 in the data set, we are able to see about 426 records out there. 20 to 24 years, we are able to see about 480 records. 25 to 30, we are able to see about 97 records in this particular this thing. So based on the age group, I can represent each of these age groups with a specific value, and then based on that make a new column which can actually reflect the type of analysis that I'm trying to do. Then to look at the outliers out there. So what are outliers? So we all have heard of the idiom, the odd one out, which means something unusual in comparison to the others in a group, basically. So similarly, an outlier is an observation in a given data set that lies far from the rest of the observations there. That means an outlier is vastly larger or smaller than the remaining values in the data set. So it is larger or it can be smaller than the values that are there in the data set. We normally, from a statistical point of view, I just told you how exactly we calculate the statistical maximum, and points above that, how we classify as the outlier, and then how we treat them. And then in the statistical minimum, how exactly those are below the values of the statistical minimum, how we treat them and put it into the statistical minimum is what is the outlier identification and the treatment that we were giving. So outliers, why do they occur basically? So an outlier may occur due to the variability in the data or due to experimental error, human error. While entry, somebody instead of entering, say 10, might have entered 100 or something like that, and it goes above the statistical maximum. And then it creates an outlier problem out there. So it could occur due to many different causes. We are not interested in identifying the causes, how it has occurred, and rectify the data. We are interested in identifying that and either remove the outlier or treat the outlier by putting it into the statistical maximum and the minimum values of the data set there. So may indicate an experimental error or heavy skewness out there in the data. So heavy tailed distribution and things like that can be looked at. So what do they typically affect? Basically, if the outliers are present, this thing may be biased towards those larger values. So that is the basic identification that we need to do. So in statistics, we have three measures of central tendency, namely the mean, median, and the mode, which help us in describing the data. And mean is the accurate measure to describe the data when we do not have any outliers that are basically present out there. This is one of the major reasons why I said in one part of the discussion that I would rather prefer to use the mean rather than any of the other things. This is by experience and not by whatever statistical rules or norms that I know of. And then mode is used if there is an outlier and about half or more of the data is the same basically. And then mean is the only measure of central tendency that is affected by outliers, which is in turn, which impacts the standard deviation and so on. So if we consider a very simple data set here, then you can see that we have about 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points here. So by looking at it, one can say quickly that 101 is an outlier which is much larger than the other values. Basically, the other values are in basically 1 to 20, and this is the only value that is there above 100 basically. So you can see that this is highly visible that this is an outlier out there by just seeing a data. But this will not be the case when it is in real time. You will have thousands of data points, and by the time you see 10 points, you already forgotten the first value. So this type of looking and doing would not work in real time, basically. So what you do is calculate the mean, which is about 20.08. Without the outlier, it is around 12.72. So you can look at the difference with the outlier, what is the value, without the outlier, what is the value. If you make a comparison, then you will be able to identify. So you can see variance is, look at the variance value, you can identify the major difference out there. You look at the standard deviation there, there also there is a huge difference when it is with outlier and without the outlier out there. So that is the type of identification that you could basically do to find the outliers. So detecting them, if the data set is small, we can detect the outlier by just looking at the data set. But what if we have a huge data set? How do we identify the outliers? So then we need to use visualization and mathematical techniques out there. So below are some of the techniques like box plot, Z, interquartile range. All these things we just saw in the code basically. So how does it basically look like when you are plotting the normal distribution out there? So some values that are below this will typically be the outliers. So the values above here will be the outliers here. So this is moderately unusual to have such low scores or such high scores. Here it is decently medium. This is not, this is the usual this thing. Most of the spread, when you do a normal distribution, all the data points would is expected to lie there, but in real time, you will not find such a ideal data basically. So z-score substitution and all we have already seen. So let me just skip through these slides and go to the next thing there. So next is to look at the reshaping part of it. So pandas use various methods to reshape the data frame and series. Let's see some of those examples here. One is the stack method. So the stack method works typically with multiple indexes, objects in data frames. So it is returning a data frame with an index with a new innermost level of row labels, and it changes the wide table to a long table type of setup internally. So if I look at this data set that I'm giving, and then I'm reading that, putting it to a data frame called the df there, then I say df underscore stacked is equal to df dot stack there. So you can see how exactly the reshaping of the data frame has typically happened before and after. We need to compare. Basically, you can see there is a new index that is generated out there when the reshaping happens. And then for each of those, this thing you will have records, you will be able to get this type of display once the reshaping is being done on the data there. You could also unstack and go back to your original this thing there. So when you do the unstacking method and then I display the top 10 records, this is how typically it would look at when the data frame is generated basically. And then you could also use a function like melt. So melt in pandas reshape data frames from wide format to basically long format and things like that. So it uses things like ID, column names. So for melt the data frame by column names is what is given. So you can say melt specific column names you give, and then you can look at the output there. So that's the type of change that could typically happen. I could subset. It is something very similar to subsetting the data set out there, basically. So you could do even a column bind and then add to the data frame new columns, new rows. Typically, could do a column bind or a row bind and add additional records, basically. So that is a reshaping of the original data. Then you could insert into the data frame also new records. Typically insert, say, I want to insert, say, with an ID, age, some of these values in the rest of the columns, and then say true. So it would enter there. So you have a data set called name, height, qualification, and so on here. So that indicates the typical this thing. So you could add new columns also to whatever data set you are having. So initially you could have created with name, age, and then you could add with qualification, so on. So that is about column binding and row binding basically. So once you are done with reshaping, you can merge different data frames to come up with the final data set out there. So merge the function there, and you could either do a inner merge, right merge, left merge, outer merge, etc. So you could also rename the data frame using the rename function and things like that. Renaming of columns could be done internally in the data set according to what you look at the meaning of the understand meaning, and then you could change the column headers. Normally, most of it is coming with client data comes with specified names, so we normally don't change, but there is an option to change out there. So we could also group data to form the using the group by function to group the data subset, and then only work on a subset of data and things like that. So you could also sort data basically using the sort values either into ascending or descending values there of a particular country or whatever data set you typically have. We could sort data and that and do it. And then the next step is a modeling where we select the modeling techniques, build the model, assess the model, and things like that. So from a modeling point of view, various modeling techniques are selected and applied, and their parameters are calibrated to optimal values there. So some of the techniques have very specific requirements on the form of data. Therefore, stepping back or to the data preparation phase is often necessary. You may have to go back and forth depending on what is the end problem and how data is being taken by your model out there, and then selecting modeling techniques out there. So selecting the actual modeling technique that is to be used. So you could either be using something like decision tree, neural networks, and things like that. So multiple techniques can be applied, performed this task for each of those techniques separately, basically. And then you could generate the test design for this, where you could do a evaluation of what exactly is being done and things like that. So you could build the model there, then you assess the model, and once the assessment is over, you go to the evaluation stage, and then try to get a beta test or whatever it is. You could even go to the client's place and start doing a beta evaluation and things like that. And then evaluation methods, how well it is performed on the test data, and then methods and criteria depend on model types, interpretation of the model, and so on. And important or not easy or hard depends on an algorithm. Though evaluating the model and reviewing the steps executed to construct the model to be necessary to be certain it properly achieves the business objectives out there. And a key objective is to determine if there is some very important business issue out there that has not been sufficiently considered. So at the end of this phase, a decision on the use of the data mining results should be reached basically once the evaluation is completed. So evaluate the results, assess the degree to which the model meets the business objectives out there, seeks to determine if there is some business reason why this model is deficient, test the model on test applications in the real application if time and budget constraints permit. Also assess other data mining results that are generated. unveil additional challenges, information, or hints for future directions out there. So you could have a review process there. Mostly there is a review process in real time, client reviews, whatever you are trying to present and things like that. And then they come up with something to go back and rework and things like that. So in order to determine if there is any important factor or task that has somehow been overlooked, then you can go back and review at this point of time. And the review for the quality assurance issues and is done, and then this could be done correctly to build the model and things like that. So here you have still time to actually rethink on the project basically, and then finally you go into the deployment there based on the scoping that was done, validating of the statistical method, the modeling that you have, the proof of project results that you had from the evaluation, final draft specifications for the industrial product could be taken up in the deployment phase. Normally, you do a deployment and things like that. Let us look at some real time example of how exactly this is done. So let me just showcase this problem here. Because this is a data set I have just taken from the I basically taken from the Python data set itself. Python also comes with a lot of data sets internally just to showcase how we normally do it in real time. I did this basically. So you can see this is a data that is pertaining to a data set called Iris, where it is specifically, if you look at the column names here, you can see that it is a data set pertaining to flowers out there. So in order to see what can be done, I have just looked at the describe command. And then once I looked at the describe command, I looked at the data types that are there in this particular this thing there. D type, it says, is object for species. So what is there in the last column is so these four columns are numeric. So the last column is D type. Species is of the object type. So you can see here that the species is either Sentosa, either Virginica or versicolor. Those are the three classes that are there in this case. So another thing that I find here is that there is no missing value out there. And since it is a classification problem, hello. We'll call the data. So you can see the info here. So you print the information there, and then you are able to see the object type. So I find the unique values out there, how many unique values are there in each column out there. And then I make a check. Since it is a classification problem, what I normally do here is I don't apply any of the missing, since there is no missing values, I don't apply any of the missing value treatment. I do not do any type of outlier treatment. I do not do any type of transformation here. Although I could do, because there's some difference here, I could still apply normalization, but normally in the classification algorithm, since most of them are robust in the machine language machine learning algorithm list, we normally don't do it only, we do it only for the logistic regression. Rest of it we just do it in real time. That is the identification that we need to do. So once we have this data set this thing, then we can identify that there are 50 samples of Sentosa, 50 samples of versicolor, 50 samples of virginica. So this is a data set that is having only about 150 data points. Basically, to make you understand, I have taken this small data set so that it is easier for me to walk you through what we normally do on major projects in the industry. So once that is done, we try to do a slicing operation on the column, last column there. So we are applying a slicing there and then prepare the data set. And then the next thing to do is directly split the data. Here I am saying the test data size should be 0.2. That means the training data set will be 0.8 in this case. So here splitting data into training and test in total, we are having about 150 rows in the 120 training rows there. So 30 are from the testing. So 0.2. That is the total 150 is there. So 20% of that will be about 45, and then 115 will be there in the test data set. So accordingly, the split will happen. I'm printing only the X test, how much is there data to just check. Then once the splitting has happened, I'm applying each of those classification algorithms are there. So I use the support vector machine here, and then the prediction and accuracy score that this model is giving me is around 93% in this case. And then I'm applying the logistic regression here, which is giving me almost about 96%. But then logistic regression in this case, whatever I applied is just to showcase. But then logistic regression is a bi-class problem. It is not a multi-class problem. This data set that I have taken is a multi-class problem. So you have to be careful that you don't apply the logistic regression. Just to showcase what may be the accuracy with this model, I just highlighted that basically, but you should not use it in real time. Then the decision tree classifier is giving me a 93 again. So you fit the model, you classify it, and then get the accuracy metrics score and things like that. Next is to apply the k-neighbors algorithm, which is giving me again 93 there. Then it gives me a classification report that the accuracy is about 97% in the KNN, basically. So this way we calculate most of those algorithms this way, and the one with the highest. Now I see that KNN was giving me the highest accuracy here in this case. So I will go by the KNN model in real time in this case. So this is how the entire steps are followed up. But when it comes to regression, basically, if it is a regression problem, so in this case, I'm showcasing the price prediction out there of this thing. This is a data set I have taken there for prices in Bangalore, basically. And then what is the targeted price in lakhs is what is the data set. So I want to make predictions. It may be based on the latitude, longitude, the address, and then what is the type of resale that is this particular area is capable of. Say places like Jainagar, these top places in the middle of the city, the resale value will be extremely high. So this can be one of the columns that majorly contributes to predicting the value also out there. So that way we look at the data set, understand the data set there. The domain is the prediction for prices, or it is the housing domain that this data set is predicting. So I need to understand how the housing domain works and then go into these steps basically. And then look at the type of data in this case. Address is object, while the number of bedrooms, bedroom or RK. So this is also an object. So how is the data stored? Number of bedroom. Okay. So that means this particular column, even though it is a numeric, it is or that particular column is thing in this particular subset that I have taken up. So anyway, you look at the data, you understand the data there, and then we normally look at a heat map, we look at a parallelogram, we try to see whether there is multicollinearity problem, things like that, because this is a regression problem. Most of it data we look or assume that the data is linear. So these things will give me an idea whether data is linear or non-linear. If it is non-linear, we would like to go for algorithms like the lasso regression and all, which is robust enough to handle non-linear regressions also, basically. So that's the whole process here. These are some of the EDAs that I have highlighted in this case here. And then you go and split the data directly. And then after the EDA, you can split the data and then you start applying the machine learning algorithms there. So in the first case, I applied a transform to the data there. Basically, the transform would either would make it into the mean and the standard deviation. So I'm applying a standardization to this data set here, and then make a split of the shape and check how many numbers do I have in each one of them, basically how many rows and how many columns do I have. And then the next step is to go and fit the model. Here I put a list of models. So these are the models I'm going to calculate: linear regression, SGD regressor, SVR regressor, support vector regressor, decision tree regressor, extra tree regressor, random forest regressor, gradient boosting regressor, ADA boost regressor, XGB regressor, and LGBM M regressor, and like that. There are many methods available in Python, so you could apply that basically. So in this case, I'm assigning all the algorithm, how many estimators I want, what is the learning rate, and all these things I can specify by the parameters that are very specific to those algorithms there. And then I finally get this score, the accuracy score here. So this indicates to me the R2 square, the root mean square error, and all these things. So anything that is higher than 0.7 is considered to be a good model, but out of that, I would go for one that is closer here. This is 79. This is the highest this thing. So for this particular data set, the XGB regressor will be the best fit in this case, and that is how that is selected, and that would be highlighted to the user out there. And then you could see the root mean square, all these things plotted against each other, and then see how exactly the behavior is basically, and then showcase that this is how the machine learning happens, and then the prediction is given basically. So the values are predicted. So in this case, whether the value of accuracy will be almost around 80% if you select the that particular algorithm. Apart from that, I want to very specifically highlight one of the real-time project there. Let me see, where did I open this? Yeah, here. So this is one of the projects where we are trying to buy a used car and then predict the price that needs to be given to the price, this thing that needs to be predicted and given to the purchase officer there. He has to predict, and then there is a maximum and a minimum value also given, so that depending on the negotiation, he can move within that range to purchase that particular car. That is the flexibility that is given. So the moment I go here, this is the front end development that has been done using PHP basically. And then this user input is taken from the front end and then pushed to the backend model. There is a Python code that is working in the background, and inside Python also in the background again are being used for statistics and all those things basically. So that coding is stored on the on my server basically, and then all I have to do is say select some car here, and then look at the particular model of that particular car there, and then give the suffix that is associated. So let me say that it is a turbo 8-seater. Their fuel automatically will be coming up. The moment you decide this, the models for only Scorpio will be displayed here. That is how we have designed this drop down. And then the fuel will automatically come for that particular suffix. What is the fuel will automatically come there. And then the year we can portray, say, 2016 is what I want to see. Odometer reading, say, let me give it as 55,000, something like this. And the number of owners who have owned this car, say, is 3. And the quality, we normally rate the car from 0 to 5, 5 being the maximum, 0 being the lowest thing. Cars that are in conditions of 0, 1, 2, people normally don't buy. Even Spinny or your Cars 24 or whoever it is will not buy it basically. So the quality is 4, let me say is 4 here. So in this case, and then you go and submit here. So once the prediction is done, you can see what was the input that you have basically given, and then what is the prediction it is giving. Since this is an ongoing project and there could be some distortions in entry values and things like that, we have given the control to the end user, where if this value it is predicting wrong because there are no major points in that particular model in the data set, then he can either go and select correct and say submit. If it is an incorrect value, he can always go back and give the right value here and say this should have been somewhere at 4.5 lakhs and then submitted. So it automatically gets entered into your database for later use. So you can see the latest this thing. I selected a Mahindra Scorpio, and then those are the values that have been predicted for the maximum, minimum, and things like that. And then there is a corrected value. Now there is a module that is running in the background which automatically updates this value this entire set of value into the data set, and this now become next time you run the model, this becomes part of the model basically. That is the level of automation that has been done, so that the accuracy of the model still increases further over a period of time. That is the thing, because we don't have major data points here. We have only about 10,000 data points in the original data given by the client. So obviously there is a distortion and things like that in the accuracy and also in the collection of data. So we are trying to make it accurate over a period of time. So it keeps on going till we are able to achieve a level of accuracy, and at a particular point of time we will be able to say that. So this is how in real time, end to end, you can do an implementation basically. That is the idea I wanted to drive in this whole session, and I'm open to questions if any is there, and then we can wind up the session. I hope it was informative.
Thank you, sir. Thank you for valuable speech, sir. It's an extraordinary session. Audience, have any questions from your side? Dear participants, have any questions from your side?
You can ask questions.
You can ask either orally or you can put it in the chat box also.
Yeah, you can put it in chat box also, and then I can take it.
Anybody, any of the participants having questions, you can put it across. The speaker is available with you here. Sir, when one of the questions they've asked, please share the data sets available for real-time projects.
See, these real-time projects, many of these are under NDA for me, so sharing is very difficult. Maybe I can create a sample of those and send it across. That's the best thing I can do.
Okay, sir.
Yeah.
Any more questions?
Anyway, I see that there are no questions at the moment. Maybe you should take my credentials from Dr. Krishna, and then maybe send in the questions sometime later.
Beck. Okay, thank you, sir. It was a very informative session. I hope the participants will be benefited with this. So any queries you can again contact. So you can collect the email details and other details of the resource person. So we shall provide you the same. Any further contacts in future, you can definitely carry it out. So I would like to thank all the participants. Okay, so the feedback link will be sent to you. Before that, just a minute. I would request all the participants to just switch on the video and keep to the screen so that we'll have a session with the resource person. Yeah. Here, Nagaran sir. And take- Yeah, I thank all the participants. So I would like you to join at 1:50 PM for the next session. So Madam Neelima will be delivering the session. So I hope you have the schedule with you. So thank you for the participation once again.
Thank you. Thanks a lot for the opportunity given. Thank you very much and wishing all the participants all the best. Thank you.
Thank you, sir. Thank you. Thank you.
Thank you.